Okay, so today our topic is derivation of ideal gas. So, what was ideal gas? In which about the you can say that if we are giving a temperature, so the particle will become apotted, and they will be having a no force of attraction repulsion because of the high temperature and the low pressure. So they will be having no volume, no shape, but more kinetic energy. We were done with the ideal gas and real gas. As you guys all know, I said you guys that in the next video we'll be talking about the derivation of the ideal gas. So the derivation of ideal gas is based on three laws, that was Boyle's, Charles, as well as the Avogadro. So because these all scientists have discussed about the ideal gas, okay, on the basis of ideal gas. So according to the Boyle's, volume is inversely proportional to the pressure, that if the pressure will become increase, so the volume will become decrease. So and Charles, what he said that volume is directly proportional to the temperature, that if the temperature will increase, so the volume will also get increase. And what about Avogadro? So he said that volume is directly proportional to the number of moles. Okay, so that number of moles will increase, so volume will also get increased. So after sum of these all, so we get V is directly proportional, inversely proportional to the pressure, and T multiplied by N. V inversely proportional 1 upon P T multiplied by N. Okay. So after removing the constant, we are having an ideal gas constant, that is R. R is what? It is the gas constant. So we can write here V is equal to R 1 upon P T multiplied by N, and you can say that here it is multiplied, it will be giving here divide, so nRT upon P, nRT upon P. Okay, and we can also write that as a PV is equal to nRT. So that is the equation of the ideal gas, and here we are having a constant, that is R. Okay, so this ideal gas is developed on the STP, which is standard temperature pressure, which values we are known about, that example 1 atm, 273 Kelvin. These are the constant values. 1 mole, 22.4 dm cube. These are the volume. So this is the standard temperature unit, or you can say that standard temperature pressure unit. If you're talking about the we can also write that as a R is equal to PV upon NT. Why? Because we have to find the calculation of R on the two parameters. One is a STP unit and second is a SI unit. Okay, so we'll be discussing first of all about STP unit. As you guys all know, pressure is equal to 1 atm. These are the constant values. Volume is equal to 224.4 dm cube. N is equal to 1 mole. T is equal to 273 Kelvin. Okay, so as you guys all know, we are having an equation that is R is equal to PV upon NT. Okay, because we have to find the R here. So So as you can see that here we are in the P, we will be putting all the values 1 atm multiplied by 22.4 dm cube and 1 mole multiplied by 273 Kelvin. And here we are, after multiplying and dividing, the answer will be 0.0821. Then we have to write all the units as 2 atm dm cube. They are downward, they will be moving upward, they will become in the minus, mole minus 1 and Kelvin minus 1. Okay, so here we have get the value of the R. Okay, this is the constant value of STP. Now we are having a constant value of R in the STP. Now let's talk about the SI unit. So as you guys all know that 22.4 dm cube is equal to 0.0244 m square, that is cubic meter. These are the constant values, we have to learn these all. 1 atm is equal to 101325 Newton meter square. Okay, and 3 is equal to temperature, that is the constant 273 Kelvin. And if you're talking about N, so that is number of moles is equal to 1 mole. Okay, so we are having an equation that is R is equal to PV upon NT. So if you're writing all the terms here, so we will get 0 point pressure. We are having a pressure unit that is equal to 0.01011325 101.325 Newton meter square multiplied by volume. We are having a value that's 0.0224 meter cube and number of mole, that is 1 mole, and multiplied by 273 Kelvin. So here you can see that we can cut meter square to the meter square, that is meter cube, meter square to meter cube, so the 1 meter will get remain. So after dividing and you can say multiplying, the answer will be 8.31 Newton meters. Why? Because Newton is remaining and 1 meter is remaining. We have cutted the meter square and meter cube, so 1 meter will remain. This meter is here and this portion is like here. Now mole and Kelvin is remaining, so we can write mole inversely, mole minus 1 and K minus 1. Why? Because they'll be moving upwards, so they will become in the minus. And Newton meter is equal to 1 joule. So we can also write that R is equal to 8.31 joule as Newton meter, because it is compared to the 1 joule. So dot M mole Kelvin inversely. Okay, so we can also write that too. So if you're talking about the next, that is, we'll be talking about the applications of the PV is equal to nRT. Okay, on the basis of the calculation of the molar mass as well as the density calculation.